Seaglaze Marine Windows are a world-renowned supplier of marine windows, doors and hatches, and we are frequently asked by our customers for help and advice on how to install and remove direct bonded mineral glass windows. In this video we're going to share with you the tips and tricks of the trade for installing ceramic printed glass, and we must thank Sika Adhesives and Chris Dowland from AD Marine Services, Sika's agent and technical marine partner, for their knowledge and help in creating this video. Thanks must also go to Bayards Marine Structures in Holland, who provided the mock-up aluminium structure that we are utilising in the video. Seaglaze have a sister company, Specialist Toughened Glass, who cut and process all the glass that is used in the Seaglaze products. Central to the Specialist Toughened Glass operation is their £500,000 digital printer that allows any pattern to be ceramically printed and fired into the glass during the toughening process, allowing full customisation of the customer's designs. We have broken the video down into 9 bite-sized portions to make it easier to find the information you might need. We hope that you will find this video helpful and of interest, so without further ado, let's get on with the video.
Hello, today we're here with Seaglaze, our partners, and together today we'll be doing a digital training on how to bond in a mineral glass window. We'll be covering tips and tricks and a commonly asked question of how to remove a mineral glass window and reapply. Our partners, Bayards Marine Structures, have kindly prepared an example window frame from a crew transfer vessel, so we're going to get started and show you some of the tips and tricks of bonding in these windows. Okay, so when we talk about thickness of bond line and the depth of the recess, this is something that's good to think about in the engineering phase. So typically, for an FRP vessel, we're looking to have a 3mm thickness between the glass and the substrate. When we have aluminium and steel, we're looking to have 8mm bond line thickness. And then we also see a typical depth of the backfill, which is the edge of the glass to the edge of the recess. This should be 10mm. In specific areas, sometimes we have to think about increasing the bond line thickness, as the adhesive is ultimately, the thickness of the adhesive is allowing the window and the substrate, the difference is allowing the adhesive to move in the middle. Now, in some situations when the vessel is at full rollover, those windows are coming further towards us, so we need to have increased thickness to handle that increased pressure. Additionally, if we have a vessel that's with a single point lift and the windows are moving more in that middle section of the vessel, then we need to think about increasing the recess to enable the windows to have the adhesive to touch up against rather than touching the recess edge. Right, so we're now at the dry fit phase. We've put in some of our spacer pieces at 8mm thick. This is really important to do in the dry fit phase, just to see that everything is going to fit in the window. We've also put these rubber blocks at the bottom so that the window never touches the hard edge of the recess, such that we are protecting the glass. Shall we get this in, Neil? So what we then do is we have our recess spacers, so we can flick out the rubber blocks once we've got the glass ready to sit on our spacers. And then the same on the other side, always making sure that we protect the glass from the hard edge of the recess. We then make sure that the window is going to be fitting into our recess exactly how we have designed it. And then it's also really key to reference that when you look around the edge of the glass, that you can see that there is a difference between the recess edge and the glass. Now, on purpose, we've made this not exactly flush. As you can see, there's just a slight distance between the edge of the aluminium and that of the glass. That's because it's really important to protect this glass edge from any potential outside impacts. Now, the backfill will protect this edge, but it's also really important to use the structure to protect it. It's just a couple of millimeters, nobody will ever see it, but it really gives just the extra protection to the glass. So now that we know that we've got our glass in position the way that we have designed it, with our gap from the structure, and we've got our 10mm recess all the way around, it's then good to let your mate move around the side of the glass and to check how we're going to hold the glass in position. So we see we've got these two suction pads, which makes a really good way to slide our wood between the structure and the suction pads, enabling us to pull the glass into the structure and creating that compression for a good adhesion. So now that we've got our spacers in position and Neil has put the wood between, which is offering that compression for the glass onto the substrate, then we know from a dry fit perspective that we are ready to move to the bond line phase of the project. Okay, so now that we've done the dry fit, we've checked that the window is square from the inside, and we've also checked that the edge of the structure and the window has still got a gap so that we're protecting that edge. We're now ready to move on to the adhesive bonding. So once we have bonded this in and allowed the Powercure 8 hours to cure, then we will move on to the backfill, which is then sealing the entire bond line and protecting it from UV rays, marine weathering, etc. Okay, so now we've removed the glass from our dry run. What we're going to do now, we're going to remove these spacers, which are at our 8mm thickness. We're then going to pre-treat the entire substrate, pre-treat the glass, and then we'll be ready for the bonding phase. So we've now reached the first phase of the pre-treatment process. Importantly, what we've done here, just to show you the difference, here we've got the aluminium structure. It's always best to bond directly to the aluminium structure, and then we've also shown you the powder coated structure so you can see the difference. But normally what we would do is we'd have just the fresh aluminium structure all the way round to bond to. Now what we're going to do here is we're going to go forward with Sika Cleaner P. It's an isopropanol base, and we go round the entire substrate, including the recess edge, in a wipe on and then wipe off with a clean lint-free cloth. Just put a little bit on, and I find just pressing your fingers into the material, and then you're looking to remove that grease. Ultimately, this grease is getting in between the pre-treatment and the bond line, which is meaning that we're not getting the absolute best out of our bond line. So that cloth is now dirty, so I'll move on with another clean cloth. I'll just go over now the recessed edge. Rotating to see, as you can see, most of that has been cleaned. Don't need to use too much Sika Cleaner P, just enough. The material moves very easily, and as you can see, we've removed some of the grease there. So then we'll go with our clean lint-free cloth and we'll wipe it off. Now this material is flashing off almost instantly, so directly afterwards we can go on with our activation step. And there we go. So we've now conducted the wipe on, wipe off process of the adhesive bond line and also the recess edge where we will backfill the bond line to protect from the elements. Right, so now we're going to go forward with Sika Activator 100. It's the next phase of the pre-treatment. We'll be going round in a wipe on, wipe off motion with our lint-free cloth again. It's important to check the best before end of date. Here you have that it's March 2025, we're in February, so that's absolutely fine. So remove the casing here. I find now it's really good to write on it and saying, well, it's the 25th of February, we write that on there, and then we know that we've got 3 months to use the Sika Activator 100 from the date of opening. So we give that a little shake, and here we've got our decanting pot. What's really important is that we don't dip into the activator. So we want to decant our Activator 100 into our decanting pot, put the lid back on, and then write the date on it, put that on the shelf, and we know we can use it for the next 3 months. What's also important to mention about Activator 100, as we wipe on, wipe off, it's going to take 10 minutes to flash off if the temperature is above 15 degrees centigrade. If the temperature is below 15 degrees centigrade, then it can take 30 minutes. So keep in mind the temperature of where you're operating. I'll just grab my lint-free cloth, pour a little bit of Activator 100. You really don't need a lot, it goes very far. And again, this is then pressing this into the substrate. And I'm going now around the recessed edge, because then we will also get a very good bond line for our backfill. So then we move on again with a clean lint-free cloth, and we're going to wipe off the material, and then we'll leave it to flash off. So that is our Sika Activator 100 applied, wipe on, wipe off, same direction. We're going to leave that now for 10 minutes to flash off. Okay, so we've just pre-treated the structure substrate. We've got 10 minutes now while the Sika Activator 100 is flashing off. So I find this is a good time where we can then move on to the glass. As you can see when you look at the glass, quite simply you can see areas of grease here. So that's why we're cleaning it, to make sure all these areas ultimately mean that we have interruption in the bond line. So we're going to clean this up now, and then we're going to move on to the activation process. So similarly as we did with the substrate structure there, we're applying Sika Cleaner P sparingly. That's a little bit too much what we've done there. Okay, and we're going to apply that with our lint-free cloth. And as you can see, that film is there, and it's just flashing off almost instantly, and it's removed a large percentage of that grease that we want to get off the glass, so that we've got a great bond line to start with. Same again, I'm pushing into the glass, wiping off with a clean lint-free cloth, and you can see the Sika Cleaner P evaporating like a wake of a boat behind me. Right, so Sika Cleaner P flashes off instantly, so we're now going forth with our Sika Activator 100, clean lint-free cloth. So we're going to go again round the substrate in a wipe on, wipe off fashion. As you can see, it's instant flash off from this material. And then back to wiping off this material. And we can leave it for 10 minutes while I go back to the substrate to prime it. Right, well let's now prep the priming phase, and then we'll be ready to roll once we've allowed both of these items 10 minutes to flash off. Okay, so we've now waited our 10 minutes in our 15-degree temperature, so we're now ready to pre-treat. So with our primer, that's Sika Primer 206G plus P, the surface of the substrate, and after that it will be ready for us to move on to the glass. A couple of little tips and tricks. Sika provide these paint brushes with the Sika Primer 206G plus P. I find it's definitely worth taking some masking tape just to wrap around the paintbrush so you get the fine edge, otherwise you get some of the pieces splail out. I find that Sika Cleaner PCA Cleaner offer a much higher degree of control, and the also really cool thing about these materials is you can chop off the head and then move down, so you can use this for multiple windows and multiple pre-treatments. Right, so first and foremost, like we did with the Activator 100, check our materials in date. We shake it up till you hear it rattle, and then a couple of minutes. So that will take a couple of minutes, get that rattled up, and then you remove this piece. I find it's always good then to write on the date, and from there you've got 3 months from when opening this material. Now this material, is really important that you take care of this material, because whatever you get it on, it's gonna be a real pain to clean. So it quickly tacks to the substrates that it is applied to. So really important. And it's also good to just mention, look, there I have it on my glove. So sometimes it's better just to say, safety first, take the gloves off, do another set, so that you don't get that on any of the substrates of your vessel, because all it does is require a bit of extra cleaning afterwards, which we don't need to do if we protect from getting it in different places. So we decant that into a separate pot. From there we take our Sika Cleaner PCA cleaner, we dip it in, and you'll find that you just need such a smidgen of this material. I find that something like that is great. And what I find as well is, rather than pressing into the pad, because that lets it run and ooze, it's better just to use it in a tack-like function. And there you can see how great these are, offering excellent control. Now it's really important to go over this once, so you can't go over this again, so you need to get a good dense priming coverage on one pass. And as you can see, it quickly tacks off, and we'll be then leaving that for 15 minutes to dry. Now then you should continue around, making sure not to go over the area twice. So I'll just show you what it's like with the paintbrush. As you saw with the PCA cleaner, you see so much control. Now with the paintbrush, because you can't pass over it twice, it really does reduce your control, and you can see how it sort of splays out. So this ultimately creates, so you need more material for one, and two, it just reduces the ease and the control that you have from the paintbrush. And what you're also reducing is the coverage that you actually get of the primer. See that run? That's exactly what ends up happening. So you try to apply a little bit more because you want to have a bit more of a stable application, and what ends up happening is you then don't get such a good prime. Worth a go, but in the end these PCA cleaners are really quite cheap compared to how much effort they save you.
How are we going to clean?
Right, so as you can see, priming with a paintbrush is really not that easy and ideal. I glided round with the PCA cleaner, Sika cleaner PCA pad, but as you see here, we've got to touch up this area, and we've also got some runs which we've cleaned up. So coming up to the recess, another really cool thing about these pads is that you can just simply cut a piece off, that goes in the bin, and then you can go again. And I do find it's nice to get a crisp edge. Does make your life a bit easier. And what we're going to do now is I'll touch up where I've missed with my paintbrush. So now I'm going to need to go forth and put the Sika Primer 206G plus P into the rest of the recess substrate and also into the backfill to make sure that we are priming the backfill ready for the two different versions of sealant that we'll be using. Pad and wipe that into the cylinder. Right, so we've now left the glass 10 minutes to flash off with the Sika Activator 100. We spent that spare time pre-treating our substrate with the Sika Primer 206G plus P. Now what we're going to do is we're going to go round our glass with our Sika Primer 206G plus P, and as we've shown, it's much easier to do it with a Sika Cleaner PCA cleaner, so we're going to use that from now on. So here, what we have is the ceramic frit. Ceramic frit is very, very important. What this does is it protects the primer, 206G plus P, from the UV rays. And what would happen, potentially, if we didn't have ceramic frit, is that this material would break down in UV. So it's absolutely critical that all mineral glass windows that are being bonded with this process, including the Sika Primer 206G plus P, has the ceramic frit to protect it from the UV rays. As you see in this situation, we standard typically say that the bond line would be 25 millimeters of width. What you see here is the width is slightly greater than that. That enables us to have some tolerance so that when we're moving the window, that we've got space between where you would see the bond line and where you wouldn't. So this gives us some tolerance when we're applying the window onto the substrate. And here you see the dotted effect that Seaglaze have put in so brilliantly, which gives a nice finish to the eye as they're looking at the window. Now what I'm going to do here is I'm going to show you what we can do with these PCA cleaners. Now, as you see, here we've got our ceramic frit is this size. Now, what we could do is we could take it all the way to the edge. There's absolutely no need for that because, as we've just said, it's much bigger than 25 mil. So we've got some tolerance in where we would apply our Primer 206G plus P. This, with a steady hand and this PCA cleaner gives us the ability to reduce the amount of masking up that we need to do. So I'm going to be brave and do it just with the PCA cleaner. Now, if we cut our PCA cleaner just like that, we just do a little check. That's the size we need. And as long as we follow that all the way round, then we don't have to do it twice. So you want to dip it in at this angle. Sometimes a little bit of a larger pot can help with that. So that is about all you need. You know, and that will probably go around the whole window. This material covers really well. So then I'm going to use my third finger just to guide myself. And there you can see how much easier it is than doing this the same size as a PCA cleaner, and now we've got to go over it to make sure we get the right coverage. Now we're not going to be able to go over this piece again because you cannot go over the pre-treatment, the primer again. So what we're going to have to do is cut a small PCA cleaner to go along that edge to be able to get the pre-treatment. Whereas in this situation, we've gone round in one pass, we've cut the PCA cleaner to the exact size that we need to do it, we've trimmed it up exactly, and that is then ready. And that is how efficiently you can work with these materials. So here we have the SikaFlex 268 Powercure applicator. It's a full system. Effectively, what we have here is the ability to take off the end cap. What we do is we hold the button in the back, which allows us to put the SikaFlex 268 Powercure Unipack into the applicator. I find this really helps because directly you can move the material into the applicator very easily. A couple of good things just to explain here. What you have with SikaFlex 268 Powercure is the main body of the adhesive and a boosted component, so you're achieving a chemical cure. When we come to put the nozzle into the applicator, as you'll see shortly, then that is piercing the two separate pieces of the adhesive that is then mixed completely in the nozzle. It's always important to check that you've got adhesive that's in date. So when we come to put the adhesive into the applicator, you can see here that I'm sliding it into the two little slots, holding the pin in here, and then directly you can push it back, and you see then that it's fully loaded. Here you have a speed that varies the speed of the application, and this is also varied on the trigger finger. So I find often, unless I'm doing intricate bond lines, I put this on max and then control it from the trigger finger. New batteries, slightly bigger, so it works all day long for most applications, and then there you can see that you've got a full charge. Important to note with the end cap, it's designed that you can put in your various different nozzles. These are the two standard ones from Sika, where you have the round nozzle that's applied like this, connect them together, and then you can cut specific V's, etc. that you want, or you can have a tight nozzle as it's shown here, or you have the quite standard use for the adhesive bead, the V-cut nozzle, and this is connecting to the applicator, doing all of the mixing in the nozzle. Now, just good to mention, these end caps, they come as spare pieces, and these two flanges here and here are designed so that if there was too much force coming through the applicator, that these would fail rather than having the material coming out within the gun. So that's just good to note, to have a couple of spares around. So when we come to assemble the applicator, we put the end cap in position. We then put our nozzle into position like so. And we put the end cap on, install, and then that's pierced the two components of the adhesive unipack. So what we'll then do is we'll move on to just purging out some of the unit. So what you'll hear as we start up the applicator, you'll hear quite a lot of mixing in the initial period, and from there, right at the end, you'll hear a couple of cracks and pops as it's coming close to completing the mix, just like that. And then you'll see a tip of the nose, and there you hear the gear change, and then the material is about to come out. So we purge off 150 millimeters so that we know that we've got a stable mix. And that noise there is the retraction, or automatic retraction of the pin, so you're not continuously pumping out material. Right, so what Neil is doing now is he's gunning out the SikaFlex 268 Powercure. He's putting a continuous bead of material such that there's no break in the material and no opportunity for air entrapment. What you can also see is Neil is pulling the applicator towards him, which once again gives him the most control in how he is applying the material. And he's also applying the adhesive on the outside of the spaces such that we have a continuous bead of adhesive. So with SikaFlex 268 Powercure, you have a stable open time of around 30 minutes. So now we're about to get the window bonded into position. Right, so on purpose we're being careful to touch only the edge of the glass, so not the area that's got the pre-treatment on it. We're offering it up with two of us to get it exactly where we want it. And we're putting our bottom recessed spaces in so that we know that on the bottom and the top we have the exact space that we designed to have, the 10 millimeters. Yeah? Is it central on your side? So what we're now doing is compressing the window towards the substrate using our pre-dry fitted system in order to bring the window towards the substrate and can compress up to the spaces that we put in to the joint. Okay, so what Neil is doing in this situation is on one part he's forcing the excess 268 Powercure into the joint to stop any air gaps and to make sure as much is in the joint as possible. Secondly, he's also cleaning that area so you don't have any lumps and bumps, because that can make it more difficult to tool the backfill, because you'll get an overcapacity in some areas and an under in others. So this gives you a more consistent ability to tool the backfill, much like you see just here. Neil will work that into the corner so you've got a consistent backfill to work with. Lastly, what you see Neil is doing is he's removing any excess 268 from the glass or from the ship structure, which ultimately means that it reduces the amount of cleaning. This is far easier to clean 268 now before it cures, while you've got the chance to get it while it's wet. Now, SikaFlex 268 Powercure will take 8 hours to cure to 80% of its full strength. It will then, much like an electric car, it will cure quickly to 8 hours, and then after that, its last 20% will happen over a 7-day period. From the cure of the 8 hours, we will then be able to backfill the joint, and we can release the fixation pins because it will have sufficient strength to hold most glass windows in. Of course, if there are really big windows, very heavy, then it's worth considering that maybe a little bit extra time is required. So we've applied the masking tape around this area to make sure that we protect the substrate from the primer. This is completely your choice, application dependent. We're going to remove the masking tape so that we can then apply the backfill, and we find that it's much better to apply the backfill without the masking tape there, because if you remove it at the point that you have the backfill in position, it can sometimes drag the adhesive, which can make finishing more difficult. It also hides in some areas the hard, crisp edge that you're looking for, so we find it's much easier to remove it now, backfill, treat to that backfill and that hard edge, and then you get that crisp finish we're all looking for from windows. Right, so we've now bonded the window in. We've also gone round it, as Neil showed you, with pushing the material into the bond line to make sure we've got a full bond in that area, and it also means that we've then got an easy backfill to go into. What's always good at the end is just to check, as you can see there, you see a good distance between the edge of the substrate and the edge of the window. You can see that the window is sitting slightly back from the edge of the substrate. Again, we do this so that that's an extra protection to the edge of the window, which is the weakest part. If it was to take a shock from there, the window will crack. Okay, so once we finish using our 268, SikaFlex 268 Powercure, then it's always good to remove the tube, the unipack from the applicator. And I find, what you can do is you can put in the nozzle, because the two materials are separated like you see here. You can see the main body of the material and the boosted component, and because that's completely separated, we can write the date on there and use this material, the rest of what's available in here, within the next 7 days. We're coming to the point now when we're ready to backfill. So what's important now is that we need to reactivate the prime surface of where the backfill will go. So that's on the edge of the recess and also the cavity down there. So, you know, we've written on this so we know that we can use this from yesterday. We are going to pull out a bit of material because we never want to go into that, because otherwise we're double dipping and we could contaminate what's in there. Put that over there. What we've done is, with a spacer, we've got our lint-free cloth, we've got our bottom edge and edges around so that we can pre-treat that cavity. So we've got our wipe on, wipe off. Right, so then we continue working our way round with our wipe on, just to reactivate prime surface. Okay, so now with our dry lint-free cloth, we're then going to just wipe off, just so we can finish the pre-treat of the backfill and the reactivation process. Okay, so what we're going to do now is that we are going to pre-treat the internal surface to reactivate the surface. So again, using Sika Activator 100. We're going to be doing this in a wipe on, wipe off motion.
we get our lint-free cloth, fold it around a spacer, and then you get the ability to just get that tool up around there, wipe off to finish the reactivation, and there you have it. Quick and simple, we've reactivated the internal and the external part of the backfill, which allows us now to crack on with backfilling the recess, so we get that nice crisp outer edge, and more importantly we protect the external edge of the window, and added protection so that if anything was to hit it, then we're doing our best to protect the edge, which is the most sensitive part of the window, and we're also protecting the entire bond line from UV and the marine elements that the ship will face in its life cycle.
So what we're going to do today is we're going to show you two options for the backfill. One option is the WS605S, which is a silicon Sikasil WS605S. The other one is SikaFlex 295UV, which is a polyurethane adhesive sealant. You've really got a few different options here really, and it's very application dependent on how you go about it. Here we have monolithic mineral glass. If you had laminated glass with either an EVA interlayer or in some situation a PVB, then you would need to use the silicon Sikasil WS605S. This is because the polyurethane adhesives and polyurethane adhesive and sealant can interact with the EVA and PVB layer, which causes a situation we often call fogging, which is basically contaminating the interlayers in the glass. On the other side, the other options are sometimes people don't want to use silicons, so when working with monolithic glass, when you've got painting going on with metal vessels, silicon can cause contamination, so people go over to polyurethane, which is where the 295UV comes in. Both sealants are very easy to tool and work with, and we will demonstrate that now to you. So what Neil's just done here is he's stabbed the unipack here. There's no need to cut the whole area off. That stabbing will give enough flow of the material, but at the same time, if you were to cut the whole thing off, it can be very messy. This just makes it much easier to load the applicator. And you have put the right bloody ends in. So what Neil is doing here is he's now applying the Sikasil WS605S. As you can see, Neil is gunning out slightly more than the actual recess area. There's a reason for this, which we'll show you in a bit more detail shortly, but effectively, by applying slightly more than the edge of the window, shortly we will compress this material into the backfill, which will make sure that we've got no air gaps between the bond line and the within the backfill recess. It also makes it far easier to tool afterwards by pulling the filleting ball or the palu around the edge to remove that excess material, rather than having not enough material to work with. Okay, so now Neil is showing you the SikaFlex 295UV. This is the polyurethane sealant for the backfill. This can be used when you're working with monolithic mineral glass, but again cannot be used when you're working with laminated glass where you've got an EVA or PVB interlayer that is exposed.
So here you see that Neil is compressing the material into the backfill to make sure there are no voids. And now he's working on the side of the SikaFlex 295 UV, the polyurethane sealant. So the job of the backfill is part aesthetic and part, of course, to protect the bond line from the marine elements and the UV, and also to protect the window edge from any impacts on the edge of the surface right of the window, which is its weakest point. The part that's aesthetic is what you'll see shortly after, which is when Neil is then tooling it off to create that really crisp external finish. Neil is doing now is he's spraying Sika tooling agent N over the surface and also over the Pelu, the tool that he's going to use to create that crisp edge finish. First, he's going to remove the excess material from the recessed edge. This is going to do two things. It's going to create that crisp finish, but it's also going to push any of the last material into any void space that's within the backfill. Tooling agent is really good to use to remove the material, because what's happening is it's giving a form that makes it easy to pull the tool across, but at the same time it's allowing Neil to clean the edges by keeping the surface wet with the tooling agent. It's important to get the glass and the edge of the structure as clean as possible while you're in this phase of the finishing of the glass recess, as this is the easiest phase to remove the excess material. As you can see, the Pelu with the tooling agent is allowing Neil to clean the edge of the substrate easily. By continuously applying the tooling agent N, the material easily comes off of the substrate and is easily tooled around the edge of the finish of the sealant. So Neil is now going through his final finishing phase, and it's really important to stress at this phase that not to leave any excess material, excess sealant on the structure edge, because ultimately this makes it much more difficult to clean. Neil's using now a little bit of tooling agent N on a lint-free cloth just to pull off any excess material to clean that edge, so we get that nice crisp finish and nothing to do afterwards with any further cleaning. So what Neil's doing now is he's applying the SikaSil WS605S silicone into the internal side of the backfill. Much like the external side, he's overfilling the joint such that the material can be pushed in to fill any voids in the backfill. This will then create a really nice crisp finish on the internal surface of the window. So Neil's now flattening and pushing in the excess material to make sure there's no voids in the internal backfill. This also gives an easier surface to work with on when you're tooling off the edge to give that crisp external finish or internal finish in this respect when using the Prelude. So same again, Neil is using Sika tooling agent N to make for an easy movement with the paler across the internal face of the backfill and removing the excess material. And whilst moving with this motion, it's also compressing the sealant up into the joint, which means that there won't be any voids within the internal backfill. As you can see, Neil continues to use the Sika tooling agent N in order to be able to easily work across the surface of the sealant, meaning that he's not getting any dragging in the material, and gradually removing slightly more material to get that crisp finish that he's looking for. So Sika Cleaner P is a great material to remove any excess material from the substrate of the ship. What you do not want to do is put the Sika Cleaner P anywhere near the sealant, as this could contaminate the joint.
So we're here today now, having bonded in the window into the structure. We're now going to show you some ideas on how to remove it, because this is one of the big questions that we're always asked with bonded in windows, is how do I actually get them out of the structure. With us at Seaglaze having our own glass plant, this allows us to actually push glass through very quickly. So if there was a damaged window, broken window, we can run a glass within a day, and we're going to show you how to remove a glass so that the downtime for the vessel is absolutely minimised. And using the Sika Powercure, the cures within 8 hours, the vessel can be back at sea in a very short space of time, which is obviously very important to our customers.
Okay, yeah, so as Charlie mentioned, we're now going to show you about how to remove a window, a commonly asked question. And yeah, basically, to give you a bit of a view, just a few materials required. Firstly, you need a scalpel-like knife, which will show you exactly what we do with it in a minute. Then you need a straight pick, quite regularly used in the automotive industry. Really important is what you see here, which is a little slot over it, which is used to carry the cheese wire through from the recess to the outside of the direct bond window. And then a cheese wire with handles, which we'll show you how to install shortly, which ultimately pulls through the material, grating it as it goes. And then some pliers with a pointy end, such that you can pull the cheese wire through when we come to that phase. So yeah, we're going to show you how to do it now.
Right, so now we're just going to cut ourselves a slot through this is the 295. Being careful not to cut the structure and affect the paint. So I've cut myself quite a generous slot.
So Charlie there is indicating where the hole is with his finger, and Neil is now pushing the straight pick through with the cheese wire connected. So he's going through the backfill and then through the adhesive of the SikaFlex 268 Powercure. And then, as you see, will come out at the bottom. Neil has pushed the straight pick through, and Charlie is now able to pull the cheese wire
I've got it
out
now
from the recess.
So now we're going to just cut the end off.
So now what you do is connect the handle to the cheese wire. So it's always helpful to have a cut straight piece of cheese wire. Thread that up through. It's actually easier without gloves on. So there it goes. So you just see it hits the edge, and then you can pull that up through. Then you thread the cheese wire through the hole. Come out the other side, fold it over, and then tighten it from that side, and then pull the handle up, which holds it in position for the next phase of the process. So that is now hard and fast. So now Neil can connect his on that side. So make sure at this point you get a decent amount of support. Of course it's going to be much easier when you're on the ship, because the ship will hold itself. And as you can see, the cheese wire starts to cut through the layers of 268 Powercure and the backfill. So it's always good to get the suction cups on early in the process, just because sometimes you get moving when you come to remove. So give them a good shake to check that they're on there tight. Oh, snap.
As you can see here, because of the time constraints we're working under, the backfill hasn't fully cured. It's skinned off, but it's still wet in the middle. But the Powercure itself is fully hard, and we can see it here. That's fully cured and hard. So that is representative of what we have to cut through with the cheese wire. The backfill 295 and the 605 can take up to 2 weeks to fully cure. Although it will feel much harder on the surface, actually if you cut this out within 2 weeks you'd still find that would be soft. We don't have 2 weeks to wait to show this demonstration, but all the methods that we've just shown will work whether the window's been installed for 2 days or 2 years.
So here we've got all of the products required to proceed with window bonding, for direct bonding of windows. Just like to talk you through some of the products. We've got the applicators here, so electric applicator for 268 Powercure, which is a 2-component adhesive curing with the booster that you see here in the top part. What's really great is with this product you can leave the nozzle in the position, and this material can still be used within 7 days as long as the nozzle is put straight back in. As this stops any contamination getting to the 2 components of the product. What we've also got is our PPE, our suction pads that ultimately hold the window in position while the adhesive is curing. We've also got our nozzles, so there's a couple of different forms of nozzles that can be used with 268 Powercure. You've got the round nozzle that can be cut to the shape that you require, standard V-cut nozzle which will gun out the bead requirements that are needed for window bonding, and there's also for larger situations, then you can use the large nozzle that can be cut to exactly the same size that you need for those windows. So if you've got a situation where you need a 35 or 30mm width bond line, then these are brilliant for that, because you can gun out the exact material you need for these nozzles. Then we move over to sort of pre-treatment and setup. So here you have the Sika Cleaner P, which is used to pre-treat the aluminium in this situation, GRP or steel. Its ultimate job is to degrease the surface from any of the contaminants. Then you move on to the activator and the primer. So Sika Activator 100 is a wipe-on, wipe-off material with a lint-free cloth. Then Sika Primer 206G plus P, which is applied easily with a PCA cleaner. You can cut it down numerous times when you're using it. You always want to decant the primer activator into another clean unit, so to make sure that you don't get contamination into the tin when using it. Yeah, so we have a couple of options with backfilling of direct bonded glass. As you can see here, we've done a separation to show you the difference between, here is the WS605S, which is a silicon sealant product, and on the right hand side you see the polyurethane of SikaFlex 295 UV. Both are exactly what you need for UV protection, marine weathering, and are very easy to tool. Of course, some companies prefer not to work with a silicone due to painting and the effects. Tooling agent, as you'll see later in the video, is really important for tooling off the seal. It gets applied to either a filleting ball, which you'll see we use later in the video, or to the tooling pads that are cut to the shape to get the exact shape of the backfill that we're looking for. And tooling agent makes it very easy to move that pad or filleting ball over the sealant and provide a really good motion and an easy flow of the material. Yeah, then moving on, we've got our lint-free cloth and also cleaning wipes, etc. Yeah, just lastly, some of the other aspects that you need when direct bonding. Ultimately, the thickness is really important when it comes to bonding windows into the shell of a vessel. For the different types of substrates, whether it be FRP, aluminium, steel, the difference that the glass has with the substrate in thermal expansion properties means that the thickness is actually allowing the adhesive to elongate, expand and contract. Therefore, you have different thicknesses that are required for the different types of situations, materials, and also if there are any special situations like rollover or lifting the vessels. And the thickness of the adhesive will allow the window to move during these type of operations that the ship goes through in its life cycle. So thickness spacers are very important to make sure you get the thickness that you've designed and are looking for. Lastly, packers are very important as well to make sure that when you're positioning the window, normally you put the packers on the bottom, which you'll see later, and these hold the window in position exactly so you get an even separation around the recess or the surface that you're bonding the window to. So yeah, these are the materials you need for window bonding.
We hope that you have found these videos of interest, and if you have any further questions or queries, please do not hesitate to contact us at Seaglaze. We can provide a complete glazing package including all of the adhesives, sealants and primers that are necessary for the installation of Seaglaze ceramic printed glass. Also, we would like to acknowledge and thank our customers Sunseeker, Diverse Marine, Safe Haven Marine, Oyster Yachts, Good Child Marine and White Shipyard, who have kindly supplied the vessel images that have been used in these instructional videos.